Welcome back. Now that you understand how series circuits work and how parallel circuits work, let's dive into understanding an important mathematical equation used to build electronic circuits. That equation is known as Ohm's law. All right, in this video, first we're going to revisit the concepts of voltage, current, and resistance we talked about in lesson A1. We will specifically walk through how these concepts form the main variables we will work with in the Ohm's law equation. Next, we'll talk through the Ohm's law equation, and then finally we'll work through an example using the Ohm's law equation when designing a circuit and see how our calculations affect the outcome of the circuit. Okay, I know some of you are panicking because I just mentioned we'd be looking at a mathematical equation. So before we launch into learning about Ohm's law, I want to first mention that if you need to skip ahead in this video, you can. You can get through all 4 levels of our Intro to Robotics course without ever calculating the Ohm's law equation yourself. The instructions we give you from designing simple circuits here in level A, all the way through the complex circuits in levels B and C, and even when you build the robot in level D, all the way through, we will tell you which resistor values are appropriate for the projects you're building. Now, I would still encourage you to watch the next 2 sections of this video because understanding that there is a mathematical relationship between voltage, current, and resistance is actually an important concept in electronics. And after you finish all 4 levels of this course, you will likely want to design complex circuits or make major customizations to your robot. And in those cases, knowing how to calculate which resistor you need to use is actually pretty important. So with that said, let's jump into the math. All right, when working with circuits, it's helpful to understand the mathematical relationship between the battery voltage, current, and the amount of resistance your circuit will provide. And so to calculate this mathematical relationship, we first need to do a quick review of the variables that will appear in the equation. We talked about voltage, current, and resistance back in lesson A1. Well, let's do a quick review. Voltage is the difference in charge between 2 points, measured in volts. Current is the rate at which charge is flowing, measured in amps or milliamps. In the Ohm's law equation, current is represented by a capital I. All right, and resistance is a material's tendency to resist the flow of current measured in ohms, or the Greek omega symbol. Okay, now remember, think of voltage as the potential ability to do work. The current is how fast the work is being done, and resistance is anything keeping the work from being done faster. All right, voltage, current, and resistance in a circuit are mathematically related. Ohm's law can be used to determine the voltage, resistance, or current of any component in a circuit. And if you have 2 out of 3 values, you can calculate that third using a little bit of pre-algebra. All right, so the equation looks like this. V equals I times R, or voltage equals current times resistance. So to use this formula, you need to ensure that you convert all your values to the following units. V is in volts, R is in ohms, and I is in amps. Okay, a quick note on the current, which we see here as a capital I. This is the most problematic unit as current is often in milliamps and must be converted before using it for Ohm's law. So if your value is 10 milliamps, you would need it to become 0.010 amps in the formula. Remember, a milliamp is 1/1000th of an amp. Okay, so what if you need to solve for current or resistance? The formula can be manipulated to solve for these. So it would be current equals volts divided by resistance, or resistance equals voltage divided by current, right? All right, let's move on. Okay. Let's actually do a quick check-in. Is your head spinning? Do you feel like that was quite enough information in math for today? Okay, if so, no worries. Go ahead and fast forward to the next section where I walk you through calculating the equation for a real-life example circuit. But, don't stop watching this video. The last part of this video is a review of the info we've just covered in this video and the last video, and that's actually important to review before you tackle the activities for this lesson. But if you love math, hang out with me for a few more minutes and we'll walk through the calculations and you can brag to all your friends that you know how to calculate the appropriate resistor value for a circuit. Let's say you have an LED with a forward voltage of 2.8 volts. with a current limit of 10 milliamps and a supply voltage of 3 volts. The formula you would use is resistance equals the supply voltage minus the LED's forward voltage divided by the desired current in amps. Okay, so start by subtracting the LED's forward voltage of 2.8 from the supply voltage of 3, and then dividing that by 10 milliamps, or 0.010 amps. This leaves you with 0.2 divided by 0.01, which equals 20, or 20 ohms. This means that with a supply voltage of 3 volts and an LED with a forward voltage of 2.8 volts, you would need a 20 ohm resistor to limit the current through the LED to 10 milliamps. Okay, well, 10 milliamps is well below the limit of 20 milliamps. However, LEDs need a little current to turn on, so it's best to go as low as possible. Later in this course, you will power the breadboard using the Raspberry Pi. And since the Raspberry Pi is a small computer, it can only output a limited amount of current. So keeping the LED current to a minimum is actually a really good idea. Good habit to get into. Let's use Ohm's law to determine how much current the LED is allowed when we use a 220 ohm resistor and a 3 volt supply. Okay, using this formula, a 220 ohm resistor limits the LED current to 0.0009 amps or 0.9 milliamps. Comparatively, a 20 ohm resistor would limit the LED current to 0.010 amps or 10 milliamps. This means that if your voltage source was only able to supply 10 milliamps of current, you could power a single LED with a 20 ohm resistor, or you could power 11 LEDs using 220 ohm resistors. Now, you'll notice in the picture on the right that there is not much LED brightness difference between the two. So limiting the current as much as possible is the better option, especially when you're powering LEDs using the Raspberry Pi. As you can see in the photo on the right, the 20 ohm resistor powering the LED at 10 milliamps is only marginally brighter than the 220 ohm resistor powering the LED at 0.9 milliamps. So unless your application requires an extremely bright LED that needs a lot of current, you can normally get away with powering LEDs using very little current. Okay, well, I'm proud of you for getting through the equations with me. Don't worry if you didn't quite understand the math. As I said before, you will not need this equation for the remainder of this course, and you will revisit this concept in future levels. The goal is for you to understand that voltage, current, and resistance are mathematically related, and that the equation can be used when designing circuits. But if you did really enjoy this part, check out the Level A resource page on the 42 Electronics website. You can find a link to the resource page in the footer of the website, and on that page, we have a link to even more information on Ohm's law and the math involved. Okay, before you move on to the activities, let's take a few moments and review the concepts we discussed in the last two videos. First, series circuits are the simple circuits you built back in Lesson A2. They consist of a single path from the positive charge of the battery, known as the battery anode, through the components onto the negative charge of the battery, known as the battery cathode. However, most projects you build or electronic equipment you use in everyday life is built as a parallel circuits. Parallel circuits have multiple paths from the battery anode to the battery cathode, and the current passes through each branch equally, powering each branch. All right, and then in this video, we discussed how voltage, current, and resistance are mathematically related. And for the math lovers among us, you can use the Ohm's law equation to determine the appropriate size resistor when you are designing a new circuit. Okay, so that's all for Lesson A3. Go ahead and move on to the activity videos where you'll get a chance to build some parallel circuits. And then you can move on to learning how to use jumper wires in Lesson A4.